Okay guys, welcome back to Pure Math School, and today we are still continuing with our introductory work. That's the third part, basic algebraic manipulation. We're going to look at some more examples, but now this time we're going to look at division of algebraic expressions, whereby you will look at division by method of long division and also by method of algebraic juggling. Then the next thing I'm going to look at is improper algebraic fractions, how to divide algebraic fractions and try to change them to proper algebraic fractions. And let's kick off with our first example of today. We have 2x cubed minus 11x plus 6x plus 6 divided by x minus 2. That's what they want. So we are going to put, since this one is a term we're going to divide by this, we're going to put it inside the long division sign. That is 2x cubed. Then since we have no, the x squared term is not there, it's better we write plus 0 of that, then minus 11x, then plus 6 divide by x minus 2. So here we are, the thing we're going to start with, we have to, we consider this first term, which has the highest power, that's to degree 3. We divide it by the first term of this to see what we have to put up there. We have 2x cubed divided by x. The power of x is 1. If you remove that, then that reduces to power 2. So that we have here 2x squared. We multiply by every term here to get our result. So we multiply by x, we have 2x cubed. Then we multiply that by negative 2 will be negative 4x squared. Then to remove that highest term, we subtract the result. When we subtract that, we're going to have a 0 here. When 0 minus negative 4, we have double minus, which changes to a plus. So that we have a positive 4x squared. Then here, remember, this one continues, that means it was plus 0 plus 0. So that means we just pull that 11x, then plus 6. Now we go to this time is for this, we have 4x squared divided by x. That's going to be 4x when that x power of a squared term of x reduces to a power to a degree of 1. So that we have 4x going up there, which is positive 4x. Then multiply that by x, we're going to have 4x squared here. Multiply by that, we're going to have minus 8x, then here plus a 0. We subtract to remove the highest power. 4x squared, that's minus that will remain 0. Then here we have minus 11 minus minus 8. Here changes to a plus. So minus 11 plus 8. The answer is a minus 3x. Then 6 minus 0 remain minus 6. Then now this time we have negative 3x. Negative 3x divided by x, we're going to have negative 3 remaining. That's the one we're going to take up. Okay. Then multiply by x, we're going to have minus 3x. Then we multiply by negative 2. So that here we have negative 3 by negative 2, we're going to have a positive 6. We're going to have a positive 6. Let me see. We have taken there negative 3 up, multiplying that negative 3x, then minus 3 is going to have a positive 6 here. Okay. Is it really okay? Then we see that if we subtract this, we're going to have here 0 here. Negative 3 minus negative 3, we change to plus, negative and plus, that will be a 0. And here we have so let's check here. Here we had 6, here was a positive, sorry. Here we had positive 6 minus 0 remain positive 6. So here we have 6 minus 6 being 0 also. So our result is that one up. That's our quotient. So our answer finally is, we have got our quotient. Quotient is the result you get after dividing a number by another number. For this case, we have it as 2x squared plus 4x minus 3. Okay, now we are going to have our next number, which is going to be, let us get the remainder. Maybe say another number. Fine, the remainder if x squared plus 3x is divided by x squared plus x minus 12. So this is the one going to be the one which is going to be inside. It's x squared plus 3x, then we don't have the constant. It's divided by x squared plus x minus 12. Now our highest power here is 2. Here also 2. X squared out of x squared, that will be 1. So that's the one we're going to take up there. So we multiply by every term here. We have x squared and multiply 1 by x squared, then we have plus x, then here minus 12. That means there we add plus 0. Then the result, if you subtract, x squared reduced to that, 3x minus x will remain 2x. Then we have 0 minus negative 12 becomes a positive. 0 minus negative 12, this becomes a plus. So it's plus 12. Then now we see that this power is now lower than that. That means we can now stop there. So our quotient will be 1, the whole number, plus 2x plus 12 out of x squared plus x minus 12. That's a result we get after dividing that. So our remainder for this case, remember we have the form of, we have quotient, remainder over the denominator or the divisor. So here the quotient is the one you get up here, which is 1, then and the remainder is the one which remained here, which is 2x plus 12 out of the divisor, which was that, plus x minus 12. So our remainder is 2x plus 12. We go to our next example. Express as a single fraction let me say Roman 1, you say half plus 2 out of x plus 3. Now we first have to get our common the lowest common factor here. Remember how we get our lowest common factor? If I have say 4 and 2, we check one that can divide both. We have 2 dividing both 2 to 1, then we again another 2 here, we have here 1, then that one remaining 1, because we have to reduce until they're all done. Then we just multiply this 4, so the common factor will actually be 4. If you multiply that, common factor will be 2 times 2, which will be 4. So here for this case we have x and that, since they are totally different since they are totally different terms or expression, we just multiply them to get that. In that we have our 2 into x plus 3 down here. Then to get what will, when we divide by this, remember to get what will be here, we divide by we divide the denominator by the denominator, our common factor, the highest common factor, by the denominator, then we apply by the numerator. So now that means we are going to have here That means we're going to have here 2 into x plus 3, then divided by 2. That means we're going to remain with x plus 3. Then we multiply by this 1 to get what we're going to put up there. That means we're going to have there x plus 3. Now, if you divide this by that, x plus 3 will cancel, then we remain with 2. Then 2 multiplying that one up will be 4. So we add plus 4. Then here we get that result. We have here x plus 7 out of 2 into x plus 3. That's how we can express 1 out of 2 plus 2 out of x plus 3 as a single fraction. And our next number will be, let me say Roman 2. We let it be 1 out of x plus 3 squared minus 2 out of x plus 3, still to be expressed as a single fraction. Let's try to recall something. Remember that if you have 1 out of 4, say adding to 1 out of 2, this also the same as 1 out of 2 squared plus 1 out of 2. So our common factor would actually, the highest common factor would actually be 4, because now 2 is inside 4, so we don't multiply. For this case, we won't multiply. We just see that this one is a square of this one is a square of that, which means 2 is actually inside that 4. So for that case, we see that our x plus 3 squared here will be our highest common factor, because x plus 3 is inside x plus 3 squared. You avoid the mistake of multiplying by them like we did in the previous number. So here we're going to have x plus 3 squared as a common denominator. Then now if you divide this by that, we are going to have 1 times 1, that will be there, then minus this, divide by that, we're going to, the power of this will reduce by 1, so that we have x times x plus 3 times 2 into x plus 3. Make sure you put the bracket, because this minus is affecting the whole of the result we get from this fraction here, so that our expression will be now 1 minus 2x, then minus will affect that positive to be a minus 3 out of x plus 3 squared. So that here we have our minus 2. We have minus 2x. Then we have here 1 minus 3. It becomes a minus 2. So out of x plus 3 squared. So our solution will be minus 2 into x minus, we can put just 2 out, yeah, minus 2 out into x plus 1 to x plus 3 squared. Okay, sorry, here we had 2 times 6, it was negative 6, that was negative 6, 1 minus that, so that means this one is going to 1 minus 5 will become a minus 6 will become a minus 5 now. Sorry for that. That means here there was no factorizing out any number, so we'd actually end up with only that. So therefore we have 1 out of x plus 3 squared minus 2 out of x plus 3, giving us minus 2x minus 5 out of x plus 3 squared. That's how we can express that the fraction, those two fractions as a single fraction. The next number we're going to look at will be Roman 3. Let's say 2x plus 6 out of 7 times 1 out of x squared minus 9. Now for this case, remember what we did in our previous videos was seeing how to we dealt with how to get factors of an expression, whereby we looked at identities. If you see this expression keenly, you realize that 9 is actually a square of 3, which that means this expression alone is x squared minus 3 squared. And you knew from our previous videos, we know what this is. It's a difference of two squares, which can also be expressed as x plus 3 into x minus 3. So that means our 2x plus 6 out of 7 times 1 out of x squared minus 9 will now become 2x plus 6 out of 7 times 1 out of x plus 3 into x minus 3 from this. So that now we have here, we factorize our 2, we have 2 into x plus 3 out of 7 times 1 out of x plus 3 into x minus 3. Now you see we have x plus 3 in the numerator and also in the denominator. That means it will actually cancel out. So that remains 2 times 1 out of 7 times that. That means we are going to have 2 out of 7 into x minus 3 as a single fraction for this expression. Let us look at another example. We say Roman 4. We have here 5x squared out of x squared plus 6x minus 7 dividing x out of x squared minus 1. Now remember that this can also be written as 5x squared out of x squared plus 6x minus 7. Then when you're dividing, you multiply, but now you change the fraction. You get the reciprocal of the fraction. That's my getting the inverse of a fraction. That means the numerator will become the denominator and the denominator will become the numerator. That means we're going to multiply this x squared minus 1 out of x, same as that. So now that means we have here 5x squared out of, now these two expressions need to be inverted. Once you come across expressions, that means they may be factorized and you have more simpler fractions, because our target is to leave our single fraction in its simplest form. That means all the common terms must cancel out. So let's first start by investigating this one. We have x squared plus 6x minus 7. So since we have that, we have to see that we have a product of -7 and our sum is 6. Now for us to get a number, we get the factors of -7, which we know 7 has only two factors, 1 and 7. It's a prime number, and that means now we see if we multiply by, we insert sign such that if we multiply we get -7, but if we add we get a 6. And let us put a -1 on, or negative on 1. If we add -1 and 7 we get a +6, and if we multiply -1 by 7 we get a -7, which means actually -1 and 7 can actually fit to split this 6. Remember that method we covered in our previous videos, factorization by splitting the middle term. So that means let's use splitting the middle terms by using the factors of the product. That means we're going to have x squared minus 1. 6 is now minus 1 times x becomes x, then plus 7x minus 7. That is the whole of that given in this form. Times, now we also see from our previous example, remember that this also in that form, 1 is the same as 1 squared. So that means that can also be in the form x plus 1, x minus 1, which is a product of two squares. So now that means we have here x plus 1 into x minus 1 out of x. Now we go further, we have 5 here. This x and this x can reduce now, so that we have only 5x there. Then that over, if you see this, we can factorize out x from here. We are going to have x minus 1, this first set, x into x minus 1. Then we have 7 also that can be removed from here into x minus 1. times x plus 1 into x minus 1 out of 1. Since x cancel, reduce the power of that x. Now we're going to have here, we see that 5x out of our common factor here is x minus 1 into, now if you remove x minus 1 here, remain with x, remove x minus 1 here, remain with 7 times x plus 1 into x minus 1 out of 1. Now we see that x minus 1 is common, that means they will simply cancel out, so that we have here 5x out of, 5x into x plus 1 out of x plus 7. We can leave it in this form, or we can leave it in this form, or we can even try to open this, but it's better we leave it in this form. Now let us go to our next number, which will basically be, I think for under that we are done. We can check on another thing. That means we have finished our first set of the assignment for today. That's covering long division, and now we can check out, we can use algebraic juggling to solve these numbers that we are doing before, or else we can cover the algebraic juggling still under improper fractions. We can see the example from there. So let's go into improper fractions. Okay, an improper fraction of algebraic expressions is known if the power of the highest power in the numerator is equal or greater than the highest power in the denominator. You can see an example. Let me say x squared out of x plus 1. We see that the numerator has a higher power than the denominator. This is considered improper fraction. Another one we can see, let me say x out of x plus 1. These ones have same powers, numerator and the denominator has same highest power. Highest power here is 1, highest power here is also 1. So that means this one is also what? Improper. How about if you have x out of 1? This is also considered improper because x term there, here the x has a power 0, which takes it back to 1. Here x has a power 1, which makes it also improper. So now basically we're going to be looking at how we can change those improper fractions. We can rearrange them into proper ones, and we are going to go straight away to our examples. Example, we say divide this x squared plus 3 out of x squared minus 4x plus 5. So as usual, we're going to put this under the long division side. The first method we're going to use is long division. Then we have x squared minus 4x plus 5. Now they have same power, same highest powers, but we are going to follow first our normal way of doing it. We have x squared, that the highest power here over the highest power here, which is x squared. That reduces to 1. We put 1 up there, then that 1 multiplies every term here. We're going to have here, but here we never had a z, and x never had a coefficient, of 0. Let us put it like that, would be better. Then we have 1 multiplying that, we have x squared. 1 times negative 4 will be minus 4x now. Then 1 times that will be 5. We reduce that. That goes away. So 0 minus negative 4 will become a positive 4. Then 3 minus 5 will become a minus 2. Then now we see that that one has now become the power here is now lower than that power. We cannot say x dividing x squared. We will remain with that, means because we can't take fractions up there, we will remain here with power is x to power 0, which is 1, and here will remain x to power 1. So we have 1 out of x, which we can't put up there. We can't put fractions up there. So now we have a result as 1 x squared plus 3 out of x squared minus 4x plus 5 is equal to 1 plus the remainder, which is 4x minus 2 out of x squared minus 4x plus 5. So now we're going to look at, that is, juggling algebraic expressions as we divide this. So here we're going to try to use the denominator to keep appearing up, so that we split this into separate fractions, and so that the denominator cancels out and we remain with a simple one by manipulating this denominator up. So let's see that we have here x squared. You see that we already have a highest power of 2 of x squared there. So let's first write the all of our denominator. We want to bring about x squared plus 3. But now that means how can we change this denominator to appear like that? So let's first multiply our denominator by 1, and we try to see what we can eliminate so that we go back to x plus 3. You'll see that here we have x squared minus 4x, but we don't have x term there, so we can add 4x to remove that, minus 4x. Then we have there plus 3, but here we have a 5. That means we subtract 2. So that's like we have not changed the numerator. Then our denominator remains 2x squared minus 4x plus 5. Then now we are going to open that bracket. We're going to split that now to have that denominator separate. So we have here now 1 into x squared minus 4x plus 5 out of x squared minus 4x plus 5. Then plus now the second one, which is 4x minus 2 out of x squared minus 4x plus 5. Now we see that if we try to again use this, manipulate that there, we don't have any square term. We can't put this and divide to take it back to that. We are not allowed to divide, because division will take us a very long process. We can't say that x squared minus 4x plus 5, then we start dividing to reduce this power to suit that. That's why we are just going to end here. That means we are going to again complicate it further. We might be going back to where we are from. So now we see that this one will now cancel out, remain with 1 plus that 4x minus 2 out of x squared minus 4x plus 5, which is actually the same as what we got in our previous expression. Now we look at another number, one more number. Let's say, which number was that? That was 1. Let's go to second one too. We have x squared plus x minus 4 out of x plus 3. First method, long division. We're going to have this one inside, plus x minus 4 divided by x plus 3. So our highest power inside here is x squared. Our highest power here is x. That will reduce that power of x to 1. Multiply that, we have x squared, then plus 3x, then we add a 0 to occupy that space. Then we reduce that to 0. x minus 3x will remain negative 2x, then minus 4 there. Then we have here highest power is x, then there highest power is also x power 1, so that reduce will remain in minus 2. Minus 2 times minus times x will be negative x 2x, I mean, then negative 2 times 3 will be minus 6, negative 6, I mean, reduce that, this will go to 0. Then we have minus 4 minus minus 6, that becomes a plus, so negative, that's actually 6 minus 4, which is a 2. So now that means we are going to have our x squared plus x minus 4 out of x plus 3 being given as the quotient, then plus the remainder out of the divisor. So that improper fraction has been made a proper fraction, like that. Go to now the second method, that's by juggling the algebraic expression. We have method 2. Our question is x squared plus x minus 4 out of x plus 3. We have here x plus 3. So this x plus 3, we try to let it appear up there and try to create that using that. So we have x plus 3. To create that x squared, it's just simply multiplying by x. So that we have here x squared plus 3x. But here we have only x, so 3x, that means we can subtract 2x again to reduce it to only x. Then we say minus 4 will remain. So that now this time you're going to have x into x plus 3 out of x plus 3, splitting from that. Then minus, we remove that minus, that means we're going to remain with positive 2x plus 4. Because that minus, we have to pull it out. It's actually now going to be like minus 2x plus 4. So that if you open, we go back to that. This minus is affecting all of that to take it back there. So that here we have x plus 3 also. So here we have, this one is going, we remain with only x minus. Now we see that this x, we have this, how can we take that one up and we have something like that? That means we have here x plus 3. Then if you put our x plus 3 up there, to create that 2x, we simply multiply by 2. Then we have 2x plus 6. But now we have 4 there. That means we have to subtract 2 to bring it to 2x plus 4. So that here means with 2 into the denominator, then minus 2 to take it back there. Then here we have x minus, now we have 2 into x plus 3, that, then we have here, now this one is affecting that, this minus was affecting the all of that, so this one has split it with it. That's now that minus will also affect that too. That will now become a plus 2 out of x plus 3, which is also taking its denominator. So that here we have x, that is going away, minus 2 plus 2 out of x plus 3, which is actually what we had before, which was actually what we had here in our previous first method, which we used long division. It was the same thing we got here. So now that's by juggling, and for that number it's also done. I want to add one more example so that we can cover, we can see another way of doing juggling, because we have looked for more of long division in the first set of examples. Now let's check on this. Let's check on x, some previous example we did. We have 2x cubed minus 11x plus 6 divided by x minus 2. we try to use juggling one more time, yeah? So that here we're going to have the numerator is x minus 2. Now we have to create that 2x cubed, but we have x minus 2 must appear there. That means for us to create a 2x cubed, we just multiply by 2x squared to create that. Now we have to first multiply to see what we have. 2x, that means we have minus 4x cubed now. Minus 4x cubed, but we need minus 4x squared, but we need what? Minus 11. We do have a square term. So since we have created 2x squared, which is the minus 4x squared, we add 4x squared to remove that minus 4x squared, because we have nothing like that here. Then we put our minus 11x plus 6. So then now this time we're going to have 2x squared into x minus 2 out of x minus 2, that one splitting with its denominator, plus 4x squared minus 11x plus 6 out of x minus 2, also splitting with this denominator. This one will of course reduce to 2x squared, plus now we have here 4x minus 11x. We need to create that x squared from this denominator. We have x minus 2. X minus 2, if it sits there, how do we create 4x squared? It's multiplying by 4x. Okay, so that we have 4x squared minus 8x. Now we have minus 8x, but here we need minus 11x. That means minus 8, we need to subtract again minus 3x to create that minus 11x. Then we add the 6 now. Okay, we have the expression 2x squared plus this 4x into x minus 2 minus 3x plus 6. 4x into x minus 2 minus 3x plus 6 out of x minus 2. So we split that. We have 2x squared plus 4x into x minus 2 out of x minus 2. Then we have here minus 3x minus 6 out of x minus 2. Be careful with this minus, because this minus, if you pull it out, it must change the sign, like having minus 3x plus 6. Once you pull out that negative, that will become a positive now, then that will change to a minus, so that when you open, you go back there. You have to be careful with it so that you don't make any mistake. So here we have 2x squared, that will now reduce to plus 4x. Now there we have minus 3x. We have here minus. Now let's factorize that 3 into, we have here x, then minus there remaining minus 2 out of x minus 2. So that here we have 2x squared plus 4x minus, that will go 3. So the whole of the expression, that is 2x cubed minus 11x plus 6 out of x minus 2 can actually be given by that. So thank you for today's video. That's all we have for today. Please don't forget to like, subscribe, share, and also comment to whether you have something you want to supplement on the video or to correct, or any advice you have. Thank you. See you in our next video.